Go back on that one. Refresh that. Hello! Hey guys, nice to see you. Sorry, I'm busy trying to like multitask going on here. Check out my t-shirt. Woo! I'm gonna wear a different science t-shirt every day for this week. That's I've suddenly realized how nerdy that is. Cool, I've got everyone. Hello, hi Lynn. It's lovely to see you. Hey, Hao Ping. Oh, I've missed you guys. Oh, it's so nice to see you guys. How is everyone? Is everyone safe? Is everyone healthy? Yeah. Atia, Mr. Duncan, my neighbor sucks. Why? What is your neighbor doing? He's cut off my apartment's water. What? Holy moly. Holy moly. Holy moles. I'm getting worse and worse. Dad jokes coming out everywhere. Right, I'll do the register. Let's do the register. Oh, Atia, I'm so sorry you have no water. Make sure that you go and buy some bottled. Definitely need water for lessons. Right, who do I have? I've got Lynn. I forgot, who else have I got? I've got Libby. I've got Hao Ping. I've got Lynn. Who else? I've got Lara. Where's Lara? Lara. Ah, there's Lara. There she is. Whoop, whoop. Doing well. Audra has a problem with her Wi-Fi and she's having trouble joining. Oh, Audra, I'm sorry you're having trouble. Oh. Hopefully she can attend on something like her phone or something. That'd be fine. Still waiting on loads of people though. Still missing. There's Dom. Yo, Dom. Dom's in the house. Oh, I've missed you guys loads. I'm glad I'm back. I'm back. What's up, Zach? What's up, Mel? What's up? What's up? Got Zach. Whoop, whoop. Zach, how you doing, dude? You keeping well? You glad to be back at school? Have you missed me? You've missed me, haven't you, Zach? I bet you guys are like, oh God, chemistry lessons again. Like, this is, Mr. Duncan's got way too much energy. It's all the coffee. I've had like 14 cups of coffee today. Coffee. That's how many cups of coffee I've had since starting this morning. Hi, Sophia. Lovely to see you. Doing well. I'm going to ask, sorry I'm late. Hey, Tiffany. Lovely to see you. I'm going to ask a favor. Can I ask a favor from Lynn? Can I ask you a favor since you were first in the room? Could you do me a favor? Could you timestamp the lesson? Could you timestamp, because I recognize that other people are now starting to watch my YouTube video lessons. And obviously they don't want to have these stupid conversations. They just want to get straight to the questions. So if you could, I'm going to be doing today, I'm going through the homework that I set you guys for titrations, for moles in solution. And then I'm going to be starting empirical formula. So Lynn, could you just timestamp the questions I do in the solutions review and then timestamp when I start the empirical formula, and then you can send me that on an email, and then I can I'll add it then to the description, and then people can then just fast forward it to the bits that they want to do. Hey Ananya, nice to see you. Nice to see you, Caitlin. Oh, thank you so much, Lynn. You guys are always so great. I've got Atia, of course. I've now got Caitlin. I am missing Ryan. Hey, Amani. Nice to see you. Has everyone missed me? You haven't yet. You're like, I've missed chemistry so much. I miss being in a lab. I miss it. Okay. I just note down the times at which you start. Yes, that's right. Hey, Ryan. Great to see you, dude. I'm missing... I've got Ananya, haven't I? Yeah, Ananya's in. Hey, Ananya, what's up? I'm just missing Kayla. That's it. Just Kayla to go. I'm going to assume that Kayla's going to turn up a little bit late. Yeah, so Lynn, if you could just note down on a piece of paper what time it is when I start the review. So that'll be in a moment. And then you can just also then make a note of when I start empirical formula, and then I'll just add those in. So it's only really 2 times, to be fair. And Kayla's in. Woo, full house. Oh, poor Audra. I hope she can make it in. I've marked her as in, though, because I know that she's trying. I know that she's attempting it, and as I said, hopefully she can do it on her phone, if nothing else. Right, guys. Oh, it's so good to see you, Year 10. It's great to see you. Right, let's crack on. So I will share my screen. Share screen. Share screen. There we go. And then go that one there. There we go. Hide. I'm actually going to be investing. I'm going to buy this today. I'm going to buy myself another webcam so that I can actually keep my face in that little corner bit, so you guys can see what I'm doing, and I can do all the hand gestures and whatnot. You know, all my right. Let's crack on. So, guys, I set you homework. I'm still getting a few people who aren't submitting their homework. I'm not going to name them by name today. I'm not going to name and shame. But I really do want you guys to keep trying your best to try and get these in on time. Okay, so this is the homework I think that I set you guys. Can someone just check that this is the correct one? Is this the correct one? I could go onto the classroom and check it that way. Let's see if I can find it. Is this the correct one? Someone give me a quick heads up if this is the right one. No, brilliant, love it. Oh, that's a disaster. Let's go to classrooms. Let's see which ones I gave you guys to do. Sorry, guys, in that case, I've made, it's always tricky, isn't it, once getting this, titrations, right? Okay, so if I remove that, let's see if I can find the correct one. Documents, year 10 worksheets, you're right, it's actually the wrong one. So, okay, I will now delete, boom, right? And what I will then do is I will add that in. So insert, I think I actually have to do this on my other laptop. So that's already been deleted, delete. And then I will then insert a different one. So print out the titration one. Titration one, yeah, I recognize it now. It's always just gonna take a little bit of time, folks, just to get back into the swing of things. Right, I've inserted that. If I now click sync and then I close this one, if I close this and then reopen it, it should update for me. I really hope it does. It's not going to, is it? Come on, my other laptop says it's trying to sync. So now maybe if I close that and then reopen it, and maybe close this one again. I'm so sorry about this, folks. Yeah, it's called Titrations 1. Yeah, thanks, Ananya. I'm on it. I'm nearly there, folks. I promise. I'm nearly there. If I then refresh that, I don't know how to refresh it. It's obviously finding it a little bit tricky. See, that's now updated on one of them, but then not on the other. So if I now click off that and then click back on it, it should go on. Go on. Update for me. Go on. Do it. It's not updating. I don't know why. Oh, hang on. Oh, I'm in. No, I'm not. Oh, no. It's gone. No. Right. So maybe if I just create, that should have updated. It says page syncing. It just says page syncing. I'm gonna have to, I don't know what to do, how to do this now. That's frustrating. Should have done that relatively quickly. It's usually pretty good at this. I work on 2 Surface Pros now, folks. That's what's going on here. So if I do, maybe make a brand new one. Maybe I'll make a new one. If I do new one and then do empirical again. Sorry, folks. Empirical formulae. and then I insert a new one. Oh, it's done it. It's updated. It's updated. There we go. It's done it. Okay, I'll delete that now. Delete page. I'm in. Yay! We're in. Whoop, whoop. We're there. Right. Now, what year 10, I'm very aware that I've given you a titration and that you guys might not recognize the title of titrations. I'm going to be setting you a homework of watching a titration. I might even have one of me doing one. I wish I'd had done it. I might. Oh, I don't have any of the equipment. Anyway, let's crack on. So you guys can mark as you go. So 25 centimeters cubed of barium hydroxide. So straight away, step 1, we know the steps now, folks. Get to moles. Yeah, step 1 is moles. So we're going to have a number of moles is C times by V over 1,000. And that's because I've got V and I've got C. So I can now input my details. Number of moles is concentration 0.2 times by a volume of 25, and I'm all over 1,000 because I am in centimeters cubed. Yeah, so my number of moles is therefore going to equal, grab my calculator, 0.2 times by 25 all over 1,000, and I get 5 times 10 to the minus 3. Next, so that then is, let's label this, moles of barium hydroxide. Nice to see barium hydroxide being a group 2 metal. It's quite nice that. Just suddenly realized I quite like to, oh, there we go. I only just realized the StreamYard in the corner is a duck. It is? Oh yeah, it's a duck. Quack, quack. Did I just do that? I didn't do that. Right, step 2, use the ratio. So the ratio, what are they asking me to find? The solution reacted with hydrochloric acid. 22.8 centimeters cubed of hydrochloric acid. Calculate the concentration of the acid. So we're trying to find him. So the ratio between these two is a 1 to 2, and I'm moving in that direction. That is a mark at GCSE. Isn't titration the name of the ship that sank? No, Atia, that's the Titanic. Holy moly. Right, so 5 times 10 to the minus 3 times by 2 gives me, times by 2 is 0.01 moles of hydrochloric acid. Right, step number 3, get out of moles. And what are they after? Calculate the concentration. Reorganize my equation. Number of moles times 1,000 over V gives me C. Every single time, folks, I am doing that rearrangement. I'm showing my process. Yeah, I'm showing the original, and then I'm reorganizing it. I'm showing this is good practice, I promise. Yeah, so let's now input my numbers. This is now for hydrochloric acid. I've got 0.1 times by 1,000, and the volume of the hydrochloric acid was over 22.8, and I get a concentration of, so times by 1,000 divided by 22.8, and I get a concentration of 0.439 moles per dm cubed. That was a terrible moles per dm cubed song. Moles per dm cubed. Sorry about that. Sorry, I'll stop. Take it if you got it right, folks. Right, question number 2. Okay, so 22.5 centimeters cubed of sodium hydroxide and reacted with 25 0.1 hydrochloric acid. Right, so there's all my stuff. Number of moles. Step number 1, get to moles. Yeah, step 1, moles. Yeah, it's Christmas moles. So we've got number of moles equals C times V over 1,000. Every single time I am writing this down without fail. I've been teaching 15 years and I'm still doing that, folks, because it's good practice. Concentration of the hydrochloric acid is 0.1 times by a volume of 25 all over 1,000. 0.1 times by 25. Still got a problem with this sticky calculator. 2.5 times 10 to the minus 3. Joke over. Moles of HCl. Next, step number 2 is the ratio. Got to roll your R's, folks. Whenever you say ratio, you got to roll your R's. Roll ratio. Mr. Duncan, when checking your final concentration answer, is there an answer which would be unlikely as in like concentration above certain values being unlikely. Mel, what an amazing question. Oh, I'm so proud of you. Why won't my A-level kids ever ask me these questions? The answer is yes. So, there is actually, there's no such thing as a minimum concentration. You can always get lower concentrations, but there is a maximum concentration, Mel. The reason being is you will become saturated. So for acids, it actually varies a little bit, but there is kind of a good rule of thumb. For sulfuric acid, the max concentration is 16 moles per dm cubed. And that actually is otherwise known as concentrated sulfuric acid. It is so concentrated that it is deemed, it's like 98% sulfuric acid. There's basically no water. I actually don't even like to quote that value. I just like to say there's better chemistry in saying that there means that there's no water. It's funny, it actually makes it safer, because if there's an acid cannot be an acid unless it's in water. I know that seems strange, because sulfuric acid, H2SO4, when you add it to water, you add to H2O, and what happens is the acid falls apart to give me H plus and SO4 2 minus, and that there is what makes an acid, and that's what burns you. So if there's no water, there's no H plus. No water, no H plus. So it's actually safer to transport acids as concentrated. And that 16 molar can be applied to the others as well. HCl and HNO3 do roughly the same number. 16 moles per dm cubed. 60, I didn't scream. 16 moles per dm cubed and 16. It's a really good number to mention. You'll be you'd never calculate it. You'd never get that high. So if you ever get like 43, you're wrong. Lol. Back to this. Ratio from the equation is 1:1. That's great, which means moles of NaOH is the same number, 2.5 times 10 to the minus 3. Right, step 3, get out of moles. What are they asking for? Oh, they're asking us to do the same thing. Calculate the concentration. Number of moles times 1,000 over V gives me C. So I'm going to do 2.5 times 10 to the minus 3 times by 1,000, which just makes the 10 to the minus 3 disappear, over a volume, which was what? The volume of sodium hydroxide was 22.5. So run that through my calculator. 2.5 exponential minus 3 times by 1,000 makes the minus 3 disappear. So it becomes 2.5 over 22.5. And I get an answer of 0.111 moles per dm cubed. There we go. Calculate the concentration of sodium hydroxide in grams per dm cubed. We can do that. So we remember this. To go from moles per dm cubed to grams per dm cubed, what we all realize is that the dm has remained the same. Winner! We just need to get from moles to grams. Number of moles equals grams over rams. But I want to get from moles to grams, so I need to make that the subject of the formula. Number of moles times by rams gives me grams. So what is the relative? Now I want to get the relative molecular mass, or in that actual case, formula mass, because it's ionic. What's the RFM for sodium hydroxide? Well, sodium, of course, is mass 23. Oxygen is 16. Hydrogen is 1. Total number is 40, I believe. So we're going to now multiply 0.111 times by 40, and I get, it's got on my calculator still, and I get 4.44 grams per dm cubed. There we go. Tick it if you got it. Next. What volume, or they've flipped it, do you notice? Instead of giving us concentrate, instead of wanting conc, they now want volume. So what volume of rubidium hydroxide reacts with 25 centimeters cubed of nitric acid? Right, step 1, get to moles. Yeah, number of moles is C times by V, there's my C, there's my V, times by V over 1,000. I'm always writing down my equation. So I'm going to now get concentration is 0.240 multiplied by a volume of 25 all over 1,000. 0.2, trying to do a Welsh accent. 0.240 multiplied by 20. I don't know, I'm dropping into like some kind of crazy Rastafarian over 1,000. I'm not very good at a Welsh accent. Times by 25. So 6 times 10 to the minus 3. That's giving us moles of nitric acid, moles of HNO3. It's good to practice writing down a formula, folks. Always good. Yeah. And now we got ratio. Ratio is step 2. Ratio is a 1-to-1. Ah, how lovely. So rubidium hydroxide moles is the same number, 6 times 10 to the minus 3. And then we say, get step 3, get out of moles. Number of moles times 1,000, bring the 1,000 up, and then bring the C down. Yeah, it gives us V. So that times 1,000 gives me just 6 divided by a concentration of 0.125. 6 times 10 to the minus 3 times 1,000 over 0.125 divided by 0.15. Sorry, I said 25. So 6 times 10 to the minus 3 times 1,000 divided by 0.15, and I get 40 centimeters cubed. People wondering why it's in centimeters cubed, because I used 1,000, which means I'm in cm cubed. Winner. Next. If it was going to be to 3 sig fig, just so you know, not that they really cared. They want, give you answer to 3 sig fig? Oh, totally missed it. All my answers so far have been to 3 sig fig. I just happened to throw that one in there. Told by chance there. Right, next. So the next question is 25 centimeters cubed of sodium hydroxide reacts with sulfuric acid. Step number 1, there's all my stuff. Step 1, get to moles. So number of moles is C times by V over 1,000, which is equal to the concentration is 0.2 multiplied by a volume of 25 all over 1,000. That's going to be, so 0.2 times by 25. Oh, typed it in wrong. 0.2 times by 25 all over 1,000 gives me 5 times 10 to the minus 3 moles of sodium hydroxide. Right, what's the ratio? Step number 2, ratio. Ratio is a 1 to, no. Ratio is a 2-to-1. Yeah, ratio is 2, is a 2-to-1, and I'm going in that direction. So I'm going to divide it by 2. So 5 times 10 to the minus 3 divided by 2 gives me, divided, still got my calculator, 2.5 times 10 to the minus 3 moles of sulfuric acid. Right, now what are they asking me for? Calculate the concentration. Step number 3, get out of moles. Number of moles times 1,000 over V gives me C. Right, so 2.5 times 10 to the minus 3 just makes the 10 to the minus 3 disappear, all over a volume of 28.7. So times 1,000, because it's already on my calculator, divided by 28.7, and I get an answer of 0.0871 moles per dm cubed. There we go. Winner. Next. Calculate the concentration of ethanoic acid. Okay. I've realized I keep going just too far, that I keep going over the data. There's the sodium hydroxide. There's the ethanoic acid. Get to moles, folks. Step 1, number of moles is C times V over 1,000. Right, concentration is there in moles per dm cubed. 0.15 multiplied by 25 over 1,000 gives me 0.15. 0.15. It's my decimal place that's really tricky. Yeah, it's the one that keeps getting sticky. 3.75 times 10 to the minus 3 moles of sodium hydroxide. Next, ratio. The ratio is a 1-to-1. Ethanoic acid plus sodium hydroxide ratio is 1-to-1. So ethanoic acid moles equals the same number, 3.75 times 10 to the minus 3. Right, now what I need to do is get out. Step 3, what am I after? Calculate the concentration of the acid. Moles times 1,000 over V gives me C. Right, input my data, 3.75 times 10 to the minus 3 times 1,000 makes the 10 to the minus 3 disappear over a volume of 30.3. 30.3. So times by 1,000 on my calculator because the number's already there, divided by 30.3. Yep, gives me 0.124. If anybody put 3, you'll lose that mark for 3 sig fig moles per dm cubed. Next, calculate the concentration in grams per dm cubed. Right, so same thing again. dm remains the same, just need to go from moles to grams. Number of moles is grams over rams, reorganize it. So what does ethanoic acid weigh? Relative molecular mass. Now it is RMM now, which is just MR, by the way. That is now correct because it's covalent, because it's all non-metals. So it's a molecule, and that is ethanoic acid is CH3COOH. So that's going to be 12 plus 3 plus 12 plus 16 times 2 plus 1, giving me a total of 60, I believe. 12 plus 3 plus 12 plus 16 plus 16 plus 1 gives me 60. Right, so I need to do the concentration, 0.124 multiplied by 60, 0.124 times by 60. You're going to say I've got rounding errors, so I'm going to go back to my previous one. I don't like the rounding error. 3.75 exponential minus 3 times 1,000 makes the 10 to the minus 3 divided by 30.3 gives me 0.123762376 multiplied by 60, and I get a concentration, equals 60, so times that by my answer, which gives me 7.43 grams per dm cubed. Winner! We're done! Guys, if you can add up your scores, that would be amazing. So 1 mark, just telling you, by the way, in reality, there's loads of marks here, but 1 mark for the correct answer, 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 1 mark for the correct answer. What's it out of? It is out of 7. Yeah. Cool. What fun that was. So guys, just post on the classroom what you got, and I'll then add it to my sheet, which would be great. And now we get to start the new thing. So Lynn, if you can just note the time, 27 minutes in, we start empirical formula. Right. So title is empirical formulae. Now, do you know what? It's really nice for me to mention how Ping is given a time and it says show it. I don't Anyway, I don't know what that does, Halping. 7 out of 7, Caitlin. Superb. Well done. Empirical formulae. So there is a definition here, folks. I just was going to quickly mention, Lara, can I say, Lara, thank you so much for being such a star and coming along to some of my A-level webinars. It was really, really nice to see you at them. And I'm pretty sure that you were kind of seeing that the calculations don't disappear. They're all still there and they do the same process. This process that I'm laying down for you guys now is such great foundations for when you step into A-level. I will do at some stage some extra A-level calculations lessons with you guys. I definitely think it'll be worthwhile. But I just wanted to say thank you to Lara for coming to some of them, and I hope that you saw them as some value. Okay, so empirical formulae. Now, we've been collecting formulae in chemistry for ages. So I think the first thing we need to do is define this. So learning objectives, we need to know the definition of EMP form. Let's keep it short. Yeah, EMP formula. So we need to know that. Oh, thanks, Laura. Definition of empirical formula. What we then need to do is, I'd like you also to know other formulae types. So I'm actually going to do that first. I'm going to do that second. Formulae types. Just nice to remind ourselves of them. Then what I want you to be able to do is I need you to understand what empirical formulae is, what EMP form is, and then last one, I need you to be able to run the process. Run process to calculate be able to calculate. I should just put be able to calculate. It is to follow the steps. Calculate EMP form. Okay, so let's define it. Yeah. So the empirical formulae definition Definition. So the definition, the empirical formulae is the, notice my change in color, please do the same thing if you can, is the simplest whole number ratio is appearing again. Simplest whole number ratio of atoms of each element. I know it's long, I know. Each element in a compound. Right, now I am so very aware. You can put it in a sparkly box, spangly box. I'm very aware that literally means nothing. Yeah, most people are looking at that going, no, I haven't got a clue what's going on here. I don't really understand what that means. So what I want to do is I just want to show you the other definition. The next definition that we're going to do is molecular. So molecular formulae. So what does this mean? Molecular formulae is the, change my color, is the actual number, not the simplest whole number ratio, but the actual number of atoms of each element in a compound. Actual number of atoms of each element in a compound. So you guys have been using this forever. Let me give you an example of this. So the example of molecular, you have to do these side by side to explain this. Yeah, if we just drop away from empirical for a minute. Yeah, what this says is, if I get something like glucose, yeah, and glucose, can anyone, let's impress me, year 10, what is the formulae, what is the molecular formulae of glucose, please? Let's see who's paying attention. Let's see who's still here. I'm very aware that people kind of come and go. Who's going to be first on the first? Hao Ping nails it. Well done. Good job. Tiffany, well done. Great job. Show, amazing. Well done. Stars. Good job, Amani. Well done. Yeah, we're good. Well done, Lynn. C6, H12, O6. All right, now seriously impress me. What's its relative molecular mass? Come on. PTSD. Libby, that's amazing. Oh, that's just, I love how Dom is still me. He still has my face on his profile. I know, can you believe it? Darts. What? Darts time, boys? Oh, no. I'm going to do a keyboard slam. That's what I've got to do here. Keyboard slam. 180. Well done, folks. Dead useful to know that. Relative molecular mass of 180. So 1 mole of glucose would weigh what in grams? Oh, I'm loving these questions. I'm loving it. What would it weigh in grams? What would 1 mole weigh, folks, in grams? I bet you guys, I'm really surprised that I don't have like shock faces in awe after I did a keyboard slam. Like, guys, I'm a boomer and I'm doing a keyboard slam. Oh yes. Yeah, I am on it. I'm picking up the lingo. Thanks, Dom. Lara, no. You're trying to give, you've gone mad, Lara. In grams, boomer is the opposite of what you want to be, Tobes. Did you just call me Tobe? That's so funny. Well done, Hao Ping. You are a winner. 100, the MR in grams is 1 mole. That is so useful. Yeah, that is honest to God. I cannot tell you how useful that trick is. Now, since we're doing a bit of revision, now that we've got to this here is the actual numbers of each element, the numbers of atoms of each element in the compound. There are 6 carbons, there are 12 hydrogens, there are 6 oxygens. These are actual numbers. So what does it mean? It looks like I put null. What does it mean if I said the simplest whole number ratio? Mr. Duncan, what is MR? MR, Mel, so MR, it's a subscript R, and it actually stands for relative molecular mass. That is the new version. This is the new version of RMM. They are the same thing. They literally equals each other. Yeah, it's just this is easier. You get AR, we know you get relative atomic mass has now been shortcutted to A subscript R. That's all. Does that make sense, Mel? It's just the relative mass of the molecule using the periodic table. So the way you get the MR is 180 because carbon weighs 12 and there's 6 of them. Hydrogen weighs 1 and there's 12 of them. Oxygen weighs 16 and there's 6 of them. You add that all together and you get 180. Yeah? Okay, so what does the simplest what does the empirical look like? So empirical is the simplest whole number ratio. Well, hang on a minute. If this here is the actual number, the question is, can we simplify? That's the question. Can we simplify? And the answer is yes, we can. CH2O. That there is the empirical formulae for glucose. Empirical formulae for glucose. It is the simplest. Well done, Dom. Great job. Right. Now, since you guys have got to that, now that we get this, let's give you some questions, folks. Right. C3H6. Oh, guys, year 10. You are the best class I have ever taught. I have taught this to you properly from the beginning. Impress me, year 10. What is the name of this compound? What is the name and what is its homologous series? Homologous series, otherwise known as family. And what is, well, Lara, you're such a star. And what is its EMP form? We've just got an answer, which is amazing. So EMP form, well done, Caitlin. Smashed it out the park. CH2. Well done. Well done, Lynn, giving me the family, alkene, halping, propene, alkene. Well done. You guys are awesome. I love you guys. Propene, and the family is an alkene. Well done. Right, Lara, you can now make the class super jealous by demonstrating your amazing extension knowledge from watching all of my year 11 webinars. This compound might not be an alkene. What could it also be? Don't worry about the rest of it, rest of you guys, just let's, big brain time, I know, right? Right, next one for you guys to have a go at. Right, this one. No family for this because it's not organic. What is the name and what is its empirical formulae? You've got to know this, guys. EdXL loves that guy. Flipping neck, absolutely loves it. Yeah, next. I'll make it a bit easier to see because there we go. Laura, you are such a star. Just for the rest of the class, alternative structure is it could be a cycloalkane, and Lara has named it correctly. Lara, so proud. Well done. It could be cyclopropane. Well done. Very, very impressed. 3 commendations for you. So proud. I'll shrink that. I'll shrink that if I can. There we go. Right, guys. So answers to this guy. So this one is very, very, very important and very special. This one is hydrogen peroxide. You guys have to know of this guy. It's super important. And it's empirical formulae. Well done to Lara again. Well done, Sophia. Great job. And the empirical formula is O. It's a big surprise, isn't it? Oh, see what I did there? Oh, it's a big surprise. Oh no. Oh, stop. Okay, let's go for another one. Let's go for petrol. C8H18. Yeah. Name, family, empirical. Go. Bleach. Oh no, Lynn. Lynn, actually, very impressed that you know that. Mr. Duncan, why is it HO and not OH? Oh, sorry, I've got it right, I got it wrong. It's actually a ho. Ho. I actually realized just what I said. It's actually it's HO, but by the way, they actually wouldn't care. Sorry, Lynn, you're correct. Yeah. You're absolutely right. It should have been HO rather than OH. They wouldn't have cared, but you're right. Nice save. No, thanks, Livy, as well. I know, save. Yeah, thanks. So we've got HO. The reason being is because the O is the negative ion. Even though it's covalent, it's acting like the negative one. So it goes second in the formulae. That's why H2O is H2O and not OH2. Because the O is the negative bit, and we always put the positive guy first. Yeah. So name of this is octane. Well done, Lara. Great job. Family is alkane. You guys are amazing. C4H9 is the right answer. Woo! Yes, smashing it. Yeah, well done. As soon as you get to an odd number, it tends to cut off. So I think everyone in the room who's still watching is probably thinking, okay, I'm kind of on this. I can see where this is going. Like, I can work out these Santa Claus. Yeah, Mel. Yeah, yeah. We realize that we can simplify a formulae. The question is, why are we bothering? So, is it actually useful? So empirical, just a quick nota bene. Now we all know that nota bene means important notice. It means nota bene in Latin. Literally means important note. Yeah. So the nota bene here is that empirical formulae is almost useless. Lol. So you're like, so why are you teaching this to me if it's completely useless? The reason why I'm teaching it to you is because empirical formulae was a consequence of machines. When we started doing chemical analysis, there are 2 types. There is, annoyingly, please forgive me, chemical, and there is machine and chemical. Now, the first type of machine that you're going to come across at GCSE, and you will come across this at GCSE, the first one that comes across is called mass spectrometry. Mass spectrometry. And this literally is a machine that measures masses. It's literally what this machine does. And it's a rather lovely machine because what happens is if you have a sample that's unknown, Yeah, you've got a solid unknown sample. You're going, I don't know what this is. Yeah, you don't know what it is. Suddenly realize it's the wrong mouth. There we go. You don't know what it is. The first thing we're going to do is we're going to put it into a mass spec machine. And what the mass spec machine will give me is it will give me, number one, it'll give me the MR, the mass. Yeah? And then it will also spit out percentage data. It will tell me all of the elements. The percentage data is it will give me the elements and their percentage. So if I were to take this unknown and I put this unknown into my mass spec device, here's what I now get from this. I get told it contains, question mark, contains carbon, hydrogen, and oxygen, and their percentages are 40%, 53.3%, and the rest hydrogen. So the first step in the exam would be you're going to calculate this one. We realize it's a percentage, so it's got to add up to 100. Yeah? So we're going to now add these together, which gives us 93.3%. And then we're going to work out the difference, which will give me 6.66%. Or 6.6. 40 plus 53.3, 100 minus answer gives me 6.7. Apologies. Gives me 6.7. So that's what the machine is going to give me. Now, this is really important because now we can now create the empirical. Because what we can now do is we can now count moles. So at this point, I know that this seems a bit vague at the minute, and I'm going to do a second webinar on empirical. But here's now what I now need you to write down. Can you write down, and this is where Lynn makes a note of this, steps in, I'm going to make my pen a bit thicker. It's a bit skinny. Steps in empirical formulae. Step number 1, percent to mass. And this is the best step ever. Yeah, you just literally, in brackets, change the sign. Change, not even the sign, it's the symbol, isn't it? So I'm going to go, okay, so I'm going to go 40 grams, 6.7 grams, 53.3 grams. Right, step number 2. So percent to mass, mass to moles. Mass to moles. Percent to mass, mass to moles. Right, so how do you do it? Divide by relative atomic mass. Right, how much does carbon weigh? 12. How much does hydrogen weigh? 1. How much does oxygen atoms weigh? 16. Right, so we're going to run those through. 40 divided by 12 gives me, this is where I'm running out of space, I'm going to drag all of this lot over here. Right, so I now get, going to change my color, 3.33, 6.7, and 53.3 divided by 16 gives me 3.33. Right, step number 3, and the last step. Step 3, percent to mass, mass to moles, divide by the smallest to find the simplest ratio. Divide by the smallest. So I'm now going to divide all of these by the smallest. Who's the smallest? 3.33. And I get 1, 2, 1. And there's my empirical formula. C1H2 Oh, and you're done. Now, the great thing is the mass spec machine gave me one other piece of information. Told me it weighed 180. So if this is the simplest whole number ratio, and the real one, the actual compound weighs 180. Well, hang on a sec. How much does the simplest one weigh? 12 plus 2 plus 16. 12 plus 2 plus 16, it weighs 30. And the real one weighs 180. To get from there to there, I multiply by 6. So the real formula is C6H12O6. I multiply all of these numbers here by 6. And that's it, folks. Wow, 4 minutes of the lesson to go. Guys, that brings us to the end of the lesson. Wowza. That was an intense lesson. Stop share screen. Don't know how to do that. Stop share. Way, we're back. I love chemistry. Right, guys, I'm done. Empirical formula is finished. I will post onto your classroom. Your question sheet, folks. It's coming. I'll post it on right now for you. Right, guys, I'm going to love you and leave you. Lynn, if you could do me a favor, send me a quick email with those numbers on, with the times. I'd really appreciate it. Guys, I hope you have a great first day back at school. It's lovely to see you. I miss you all so much. I hope you're all well and have a great rest of your day. All right, guys. See you later.